Okay, our supporters. Thank you to our host, Futura. If you want to say something about Futura or after, okay. Thank you. So after, uh, okay, many thanks also to Python Italia Association, which support us with our mics for the podcast, stickers, and also I think the the machinery for the cam and mic, so everything we are using for the meetup. And thank you especially for Division Lab that physically bought all the stuff to do the streaming. And that's it. Oh, that is not. that. Okay, so who is the first? Lorenzo. Thank you.
Proviamo. Funziona. Ooh la la. It's gonna be super quick, so thanks for coming. I'm Lorenzo. I'm the co-founder of Futura, co-founder and CTO. This is our office. I'm sorry if it's not like the best place to like have a conference, but those tables are just like for us like to work. So it's not like the best like suitable place for it, but I hope you will enjoy the conference. It's gonna be super quick. In Futura, what we do is we basically are trying to change the way people are learning. Learning is one of the field in which people are like investing the most, and we are trying to introduce a bit of technology in order to let our students to improve the way they are actually learning and learning new things and improving the way of studying. This is our deck for raising around, so it's not like the best deck to show it to you, but like super quickly, the way we are doing it is we are trying to add personalization and collaboration in the way people are studying. And this is basically our platform. Is a platform where students can come in and they can get analyzed by our algorithms in order to understand which path is the best path for them to improve and to maximize their learning curve. Luca is one of our tech members of the team. Is the last one that came in, but it's growing like super fast. I'm super happy that he decided to organize this event. I mean, I didn't do anything, so it was all on him. So thanks, Luca, for all the work you did. I really hope you will have fun. And I mean, for any questions, you can ask me. You can ask Luca if you are curious about what we are doing. I really hope that this will. I mean, it's gonna be like 1 hour of really interesting like topics and discussions. So thanks for that.
Okay, good evening, everybody. Today we're talking about animals. Last time we talked about cooking. I think for today we had to change the topic in a way. What I wanted to talk about today is maybe something that will be actually something that we will definitely be seeing a lot more in the next years, and maybe something that will end the greatest data frame showdown that we've participated to in the last like 2 years or even more. So I will be talking about Polars, which is a library that takes a lot of inspiration from Pandas, but tries to solve most of its problems using a bit of a cheesy way, maybe something we don't really like a lot to talk about these days, but it's here, it's there, and it's changing a lot of the tooling ecosystem and all of that in Python, which is Rust. Blazingly fast, etc., type safety, whatever you will call it, whatever you want. Rust is a part of the developer ecosystem right now, and it's coming into Python as well, and it's taking it by storm. It's doing a lot of heavy work and heavy lifting. Polars is one of the examples, but let's just think about like RAF, which is this next iteration of Flake 8. It's becoming so widespread. It's being used everywhere by Fast API, by Zulip, by so many projects in anywhere shape, in the ecosystem. So it's coming for data frame as well. And tonight we will try to see what it can do, what its niche, and if it actually can really be an alternative to pandas, and why, when. Let's talk about like the basics. Why do we talk about pandas? Why do we hate it? Why do we love it? What are its limitations, basically? And I would like to start with this with a little, like just a really small rundown, if the pointer works. Which, okay, I know why it isn't working. Okay, great, because I used to use the keyboard shortcuts. We'll be covering a bit of pandas and the data paradigms that we have for the different libraries and data manipulation libraries. We will also cover, like, more specific in the case, try to find the use case for the alternatives to pandas. Why should and when should we be replacing pandas? Also, we will be discussing our new contestant, polars, and assessing its pros and cons, and going a bit deeper in its fundamentals, its fundamental traits, and its applications, like most common application that we might want to use, with lots of coding examples, really basic ones, but still worthy ones. And finally, we will be taking like a closer look at lazy evaluation, which is one of the key elements that makes polars so fast and really interesting to use. Finally, a bunch of references for those who are interested for this, all the stuff that I used to prepare the talk. To get started, I would like to entertain us in a small of a guessing game. If I take this quote, which is quite well known and also covered, so you have to do like 2 games in one, fill in the gaps first and then find out who said that. Maybe the first one is a bit difficult, but have you ever heard, raise your hand if you have ever heard that if you use pandas, like you should have at least 5 to 10 times the RAM in your computer to manipulate the data. So if you have 1 gigabyte of data set, you should have like from 5 to 10 gigabytes of RAM to manipulate it. You heard it. Okay. Do you remember Herschel who might have said that?
I heard it from the author of Polars, actually, but
Okay, that's a fair point. That's a competition. Okay. Is this the first time you I can't really say you see that, because you're actually not seeing that at all, but still, the first time that you hear it. I don't think you can. Is this the first time you hear about this? Like that you should have like 5 to 10 times the size of the data set that you're working with to work properly with pandas? Okay, that's fine. That's stuff that happens. So glad that you didn't have to bump into this. But actually, this quote originally came from the inventor of pandas, Wes McKinney. McKinney, exactly. And how about this other one? When scaling a data set, data manipulation becomes a problem. First, it's worth considering not using pandas at all. Where does this come from? It might surprise you a bit, but it actually comes from the pandas documentation. Which is totally okay. I mean, I don't want to like be the guy that talks bad about pandas. It's a lovely library. It's a wonderful library. It's a wonderful tool, and it will not be replaced, maybe, but really likely won't be replaced. It has a really special use case, a really expressive API that everybody like has grown with, that has stuck with us, that has set an incredibly high bar, but has some limits that we might want to address. And just to give a quick rundown, the first limits are the fact that pandas, being written in Python, its awk engine, is single-threaded. This means that also it is bound to the eager mode. So the order you execute the operation is executed immediately. So if you do, I don't know, you read the whole data set, read the whole table into memory, then you filter some rows, it will take everything into there, and it will be also doing redundant operations. This means that this boundary, this limit, means that you can do a lot of batching operations, and you can really exploit any high-level optimization strategies. So what they call like push down or query filtering, optimization, like operation fusion and stuff like that. Another point is that the way it works, it uses a lot of copies internally. There is not a lot of like zero copy. They call it, I think, COW, copy on write operation. They're not really common in pandas. So this means that when you run even a really simple query such as this one, when you want to manipulate a column where it's smaller than 0 and add all the elements in column D, you need to create a temporary data frame. And if this is not a problem with small data sets that we might be working with, especially when you're doing like exploratory analysis, but this becomes a problem the bigger the data set. And this is where the 5 to 10 times RAM comes from. And this can quickly become a problem. Not only that, appending becomes costly. One of the easiest and neatest tricks to reduce memory consumption in Pandas is avoid appending to it, but just create a small data set and then use PD concat to put them all together. That is because anytime you append, the index needs to be rebuilt every time. And this can get quite burdensome quite soon. Another point of discussion might be the syntax. It is expressive, it's extremely beautiful, but maybe it has become a bit more non-intuitive in some ways, especially since the rise of what they call the modern syntax. There was this really influential series of blog posts by Thomas Berger, who wrote Modern Pandas, that was basically like opened up a more method chaining or functional style of programming with Pandas that is really expressive, that lots of benefits. This was something that was also took inspiration from R, the R crowd, the dplyr, piping, chain operation stuff, and it's possible also in Pandas. And this is beautiful. It makes code much more readable, much more compact, much less redundant, but sometimes it makes you use something that are not really Pythonic, say using lambda functions. You have a wonderful .assign method that allows you to define multiple columns at once, but you may have to use lambda function in there, which are totally okay, but maybe you don't really, maybe you're just like a Python-like purist and you want to avoid them, especially because this apply method, which by the way is not really performant, can take in a callable, which you should define as a UDF, so as a user-defined function, which would be great. But if you don't want, and if you like work in a hurry, you can use another lambda function in there. So you have a lambda inside another lambda. If you find somebody who studied IT, I think it will call it eat your alive, because I know you have to get stuff done, but still, some kind of things about performance and readability all come in here. Still, this is beautiful, but it can be maybe improved upon. Still, I highly encourage you to use the modern method chaining based syntax. Method chaining is really great and improves on readability, and maybe you can use just the object-oriented API and interface just to define your own user-defined function to pass them through some kind of neat method such as the f.pipe. So as you see here, this is the beauty of Pandas nowadays, and how you should use it. It's like better to use according to many. Is you filter, for example, your columns instead of using the bracket notation to take your parentheses, but it's either the same. You can drop the missing values. You can assign new columns on the fly, which requires your lambda. You can query the columns instead of using .lock and using brackets, and then rewriting the name of the column and add the brackets, etc. You can do that, and you can neatly pipe everything into, say, a built-in function, such as the plotting function from Seaborn, but also your user-defined function. And this is really beautiful and allows you to create wonderful, wonderful code snippets that become really usable, really understandable. And that is all that comes down to. This is really great. But still, some may object this and say, man, maybe it can be better. Because these is just one small example, but it can get worse. And it will get much worse indeed sometimes. So these are some of the reasons why we try to go beyond Pandas. And most of the efforts that were made to overcome these problems all revolve around Apache Arrow. Apache Arrow is a wonderful framework that has grown like extremely fast in the past, especially 3 years, but it's been there since at least, I would say 10, but at least 7 or 8. And Apache Arrow is this like project that was given to the Apache Foundation that is mainly developed right now by Wes McKinney, the co-founder of that project, and other guys that are now working for Voltron Data. And Apache Arrow does a lot of things. The first thing that you might know it for is this format to represent data in a columnar way. So a lot of compression algorithms to make sure that your CSV, that is like 2 gigabytes big, because there are lots of redundant information, can be stored in a small Parquet file in the orders of the tens of megabytes. So lots of savings from there. In terms of memory, yes, but also in terms of performance. Because if you use these special storage formats such as Parquet, these data are stored with metadata that allow you to perform really quick read operations, really quick filtering operations, and lazy loading, and push down all these predicates, so like data manipulation and functions, so that they are executed down at the file system level so that only the data you actually need is read. Also, Apache Arrow brought out some language agnostic APIs to manipulate Parquet data, like all Apache Arrow data. And they create libraries, like kind of low-level libraries to work in Python, R, Julia, C++, Java, to work with this data and make and compute fast operations on columnar data. And they went so much so that they really built wiring protocols to move data across wires, like physical wires, like how they're transferred in packets. And then they also made drivers for the database, for databases basically, so that right now it is extremely easy to work with columnar data from the wire level to your database driver. And these unlocked an extreme amount of optimizations and performance, unlocked with an untapped potential, because you have efficient data types, you have fast data transfer, you have conversions that are handled in a really general, like in one way, so that you as a Databricks or another data management company can just take the APIs and build your product around it, and they will be performant. And why we're talking about this all the time, that is because this is the first step of the system. And Wes McKinney was the first one to realize that processing capabilities weren't growing not even as fast as data needs and data management. So data was becoming so big and the hardware couldn't keep up. So we had to become much more creative, much more smart in the way we manage data, so that we could be more performant in analyzing data. Just as a matter of context, the first beta of Pandas was out in 2008. So big data was just becoming a big thing. And for the data needs of 2008, Pandas was amazing, was top notch, like cream of the crop, whatever you call it. It was fast. And the way that data problems were handled back in 2000, like 10, 15 years ago, was just throw more RAM at it. Now we can do this because we have terabytes of data and we just cannot really throw RAM at them. We have to be clever about how we manipulate the data. And this was the first part, and now this piece is complete, but still what we need now is some way to manage, like to work with this data to a higher level. And these were like, we called it like query engine or data frame manipulation libraries come out. And we have a lot of them. I swear, this is the result of, these two tables are the result of all the collection tools that I downloaded on GitHub to find all the possible data manipulation libraries. But what I'd like to focus you on is that some are in memory, some are distributed, such as Apache Spark, and some are just wrappers that allow you to use the similar SQL, SQL, Pandas, or just Python code API to work on both on local databases such as Pandas, and also on Dask, on distributed cluster or data frames or data frame libraries that are used to work with cluster. Because of course, when you have to use a distributed system, the API will change dramatically. And you cannot really, one of the reasons we stuck with Pandas is the loveless syntax. But we have to change it dramatically just to adapt to, I don't know, Apache Spark. We will have to go through another really steep learning curve. So what was one of the solutions that people came up with, and the same people at the Spark themselves implement a Pandas-like API. So Pandas is, in a way, will never be overcome because its syntax is so influential, it's so clear, so expressive, that it sets such a high standard we cannot really ever get rid of it. We can work on its internals and make them better, but Pandas is here to stay and will always be here, because all the distributed and complex system took it as a reference to implement their APIs. So this brings us back, this like big parenthesis that I had to open, brings us to this place, exactly here. So now we are here and we're trying to find a way to say, okay, when, like among these, which one should I use? But also not like in general as a whole, because coming up with Apache Spark, setting up a Spark cluster for the organization can be cumbersome in terms of tech, in terms of money, in terms of people that look after it. So sometimes we just might want to stay in this realm. Pandas is so neat because it's just everything in memory. You can spin up a notebook, import Pandas, do everything. You don't need to worry about clusters. And all these wrapper libraries are great. Ray is a nice framework that is getting a lot of traction. I've never heard about Modin or Mars, but Fugue is getting a bit of traction. XRA is widely used. even like as a in the inner workings of PyMC, for example. But we don't really use them day to day. Maybe we just heard about Spark, and then there are all the clusters that we use from that, like Databricks set up for us and all these data engineering company. But we just want to keep Pandas for as much as we can. That's the point. We want to move away from it to a distributed system as late as we can, because that incurs a lot of overhead in using it, in learning how to use it, in using it properly. Because the Pandas API cannot just really be put to work like just properly, like just one-on-one mapped with Apache Spark, for example, because you have to organize clusters have to speak with each other, have to move data, share data, etc. So there's a lot of work going on in making a Pandas-like API for a distributed system. So what we want to keep is a system that can work in memory and be performant as much as we can for data sets that are like decently sized. I don't know, maybe like in the order of the tens of gigabytes, and then afterward just move to a distributed system. And Apache Spark there is still the king. Apache Data Fusion is developing quickly, which is basically a Rust plus Apache Arrow take on Apache Spark, because Apache Spark is not natively compatible with Arrow data types. Dask is nice, you hear a lot about it, but it just pandas on parallel, like on a system that makes it parallelizable. But it doesn't get rid of the fact that it's this single-threaded and that it uses up a lot of memory. So Dask is still not super efficient as you may want it to be. So the solution that people are coming up with, and in part I agree with, is using Polars. Because Polars checks all the boxes, wonderful query engine, uses Apache Arrow, but also maintains an in-memory API, and an in-memory behavior, and it is a really friendly and expressive API that doesn't force you to change the way you think about how you perform manipulation. It couldn't bear it. It was exhausted. Like it's like can do it. So why Polars? Because of course, as I said, it uses Apache Arrow. It supports both eager and lazy evaluation, which means that it can perform a push down and optimize your query plan. Instead of executing everything line by line, it can say, okay, maybe I can rearrange this stuff so that I don't have to read in as much data as I need to. It can also support hybrid streaming because it's not fully implemented, but still it can say, okay, just work on data in batches. So even if I have like 16 gigabytes of RAM in my MacBook, I can still work with a 64 gigabyte data set because I can read it in chunks and work on it in chunks. Not only that, it's multi-threaded, thanks to Rust. It has the same expressive API as Pandas, and I would dare, and I will try to show you that it is even better under this point of view. And it also performs query optimization, and it's Rust. We know it. I mean, we're talking a lot about it. We don't have to use Rust. We just enjoy it as Python because being the language that it is, it's really great that we can keep up with all the developments around the environment, and being able to use Rust in the way is nice. In general, as I was saying, Pandas, Polars has a copy and write semantics, so the cloning, like creating a copy, is free because you do not have to create a copy memory of the object. Appends are cheap. Also, you have column-rated data storage. You don't have to work with the so-called block manager, which is the entity that manages data inside Pandas. It's nicer in treating missing values. It does optimization on the bitmap, so how you'd work with missing values. It has efficient algorithms and all of the stuff that I took literally copy-pasting from their page. So they're just hyping it up a lot. And here, everything they bolster is that. It has lazy evaluation, so the dataset is only mapped into memory. So only the dataset structure is mapped into memory, but you don't have to read everything into memory, which is a great thing because the Polars knows where to find the column, maybe knows something about the chunks and the metadata, where the maximum is, but doesn't have to read everything into memory to do so. And this becomes really efficient because when we're working with 10 gigabytes of data, we don't really use it all, okay? We don't just scroll through everything. It's not like 10 lines, it's 1 billion, okay? What are we doing with that? Most of the time, we just select start from and filter in something because we need a subset of the data set. So this is really clever when we want to scale up. We move to Pandas, but not to the distributed system. And so projection can be pushed down and all this kind of nice feature, et cetera, et cetera, et cetera. And we all know this, and this is nice, and so well, they're good, but please show us something. And I wish I could, thanks to the lamp, but I think something you can kind of see. And here, I swear, there is like a PL, because polars is PL, not PD, and you read the CSV, and you can just say operations like df.filter, and then here we start to see the novelties, the weird thing. So df.filter is okay, nice, we'll know it. What is pl.call? I think this is the best thing about polars, because you can use these that are called expression to work on columns. I always found like, okay, you have to say df, and then you open the bracket, the square bracket, so maybe use lock because you don't want to get view versus a copy warning. And then you take the column and you start doing manipulation that works on one column at a time, because Pandas was designed to be more object-oriented, maybe like Matplotlib. But when you want to chain all this kind of stuff in Pandas and use like a big assign and then move on, it's a bit more difficult. And polars make this so great. Also, there is an aggregation, there is a group by, there is another PL expression here, and we're going to attack all of them here right now. And this is how it works and how it is displayed. We don't have the nice HTML that Pandas made us used to, accustomed to, but still you see that thanks to Apache Arrow, we have nice types on top where you have the columns, and you have like a decent representation and you can pretty print. One of the problems sometimes with Pandas, okay, it worked when you use an IPython, so most rep will accept it, but all the environment or the IDEs, I think, of VS Code, PyCharm have to build a special UI just to store it, just to work with it, to make it possible to display it. Polars does away with all of this and makes it much more simple to visualize, but that's just a matter of taste. Nothing changes. I really like the fact that you get the data types on top. So we saw expressions, that is that PL dot something, you PL, name of the column, and you can just chain operation inside. And these expressions don't work on their own. We have to introduce another concept that is called the context. And so basically it's a bit like, I wouldn't call it like SQL, but these are three specific verbs that are called select, that we do not have in Pandas. It doesn't have this use at least. We have group bys and aggregations, and with columns, which is a really nice thing. So these, inside these contexts, you basically, when you say df dot something, you open up a context, and inside the context, you put all the expressions. These are like easy to understand. These with columns is the preferred way to create to add the new columns to your dataset. And these are the really nice expression because they allow you to do a lot of stuff. For example, here, df.select, so I just want to take these two columns. I want an output that has two columns. And we say, okay, I want to take the column foo, sort it, and then take the two first values. I want to take the column bar, filter, so that when the value of foo is equal to 1, see that we are filtering on a different column. Doing this trick in Pandas with modern Pandas is doable, but it's a bit more cumbersome to get. And maybe you want to use a user-defined function, so define a function yourself rather than using a lambda. Because if you want to write this in Pandas, you would have to say df dot filter, maybe, and then, or maybe df dot assign, and then you say foo is equal to lambda df dot foo dot sort head 2, comma, and you go like the next line and say bar is equal to lambda df dot assign, lambda df, comma, df, name of the column, dot apply, and then maybe lambda x, where x is equal to 1. Maybe not, okay? But maybe you can do that, and it's nice that you can do it really quickly with lambdas. They're wonderful, but maybe not in production, maybe not with a big data set. Also because they really are inefficient in Pandas. Do not use dot apply in Pandas, please. If anything that has to come after this, that is df dot apply is like, it seems nice, but is low. Meta chaining is a really nice thing because you can do something like this. Also, please note that you can really rename the columns immediately here using the .alias function. You can also go well beyond this, and this is how it will look like. And you see that you have the with column, so this created this the two new columns. You can also go a bit beyond and use it with nested expressions. So see up here, for example, pl.call.names, where you want to filter so that the column names, like this is like how Pandas told us to use it. So this is like where we inherited the syntax, where the values in the column names contain this regex expression, and then you count it. Doing this in one line of Pandas is doable, but maybe beside being efficient or no, maybe it's not as fast as you would like to be. Moving on a bit again, You can it also rewrites some df.mask or numpy.where is really nice to have, but maybe sometimes a bit more cumbersome to explain. So here they maybe should rewrite some stuff so that the SPL call run random. If this, when, then, otherwise, which makes it nice to read, is a flow, as a stream of data manipulations. Also, we can do crazy stuff. Like you see, we have window functions, and you can work with them just in this way, a really like proper way. You can also do this with pandas. I've been saying that all night, and you should do if the dataset size is comfortable. Like it makes it such that you can work with it, especially if you already know it. But I would argue that it's really nice to move from one to the other, back and forth, when it's the case. But maybe this is a bit more challenging to write in pandas, you see, because you filter where this is not null, then you do the sum, then you add this suffix to the name of the column. You can't really do this in pandas. You would have to use dot rename eventually on that column as well. You can also reverse it, etc., etc., etc. This is nice, but still remember there is like performance gain to be used in this and performance loss that you may want to use in pandas, because the dot apply syntax is nice, but you need to do extra work if you need to find the optimal implementation. Keep in mind that this tends to be optimized. So this is like a group by .ag. .ag in pandas is there as well, but needs you to pass like a dictionary inside here when the key is the name of the column that you want to create, and then there is the expression. And maybe you'd be better define it as a user-defined function. So there goes a lot more work in doing this in pandas. It's doable. It's fine. It's beautiful still, because pandas is really elegant. But maybe not in production, maybe not when you need to write like a proper clean stuff that needs to be there immediately, easy to read, and maybe when you don't want like to write 5 functions on your own. You can also see here that we're starting to get in the crazy stuff, like where you have a data set, you want to perform lazy operations on that, and maybe when you want to create special column integration, this can be done in pandas, but still a bit more difficult to get. But still really expressive, and I would argue that this is really expressive. Like it's easy. You don't even know the library, but because it's modeled after pandas, it's really easy to read. And I would say, like going through the motions of it, it's more natural to read through and to know what it does, even if this is the first time that you go after it. Like if you see that, it also supports time series data, because if you didn't notice, but I think most of you have already, you do not have indexes there. How do you work with time series data, for example? That's where indexes were made with. Pandas is actually an acronym for panel data analysis. Well, you have wonderful support by group by dynamic and group by rolling that allow you to work with data set and date times data. For example, an Apple stock, you can just group by dynamic on the date every 1 year and aggregate the column and get the mean. And you can also add back the date, because you can take the original data and you say with column date, dt year, alias year. This is really similar to what you would be doing in pandas anyway, because it was so influential that it came up with a really featureful and expressive API that everybody like had to use eventually, just because the syntax was so clear that they just couldn't go away with it. It was so beautiful. You can also do a bit more complex datetime operations, but I mean, you can just do time series resampling, you can do interpolations, you can fill null, etc., and get something that maybe looks like this in just 1 line. You can get also with pandas still, nothing to take away from it. And the point is why we need to use context. I'm getting to the end of it. Context, these context functions are used because everything inside the context here is actually executed lazily. So it gets automatically, with no effort whatsoever, optimization. Because the query plan gets analyzed. So for example here, he knows that he just has to use the column bar and sum over it, aggregating over the function, the foo column. And also, what Polars will do automatically is use all these parallelization, multi-threading, etc., to create a query plan that just takes this, then does the operation where it is needed. Whereas pandas will just iterate it over it row by row, because it's single-threaded. Just very, very, very last bit, just that, okay? Using these lazy execution is really nice. You don't see here, but you see here this verb, scan CSV. When you're reading data from memory, you can say scan CSV or scan parquet to read the file lazily. When you read it lazily, it is not read into memory. It's just mapped. Its structure is mapped. And then when you want to get the result, you just collect it. For the rest, it's just the same thing as you would have used like in normal pandas or polars. So this is how you read it lazily. This is just a regular query that we add. And by adding 2 lines, you get the whole set of lazy evaluation. The same goes with data that you read from the internet. When it is not stored locally, you can say pl.read, but the .lazy verb will tell polars to use lazy evaluation on it, etc. Same thing. And finally, when you already have a data set in memory that comes out from a process, because maybe you're writing a script or you're working on an exploratory level, so you know that you want to use like a mixed or hybrid of eager and hybrid evaluation, you can cast at any time a data frame into lazy evaluation by using df.lazy and then writing your own query and then collect it again. And this is nice, and this might not be the future. Like I wouldn't say, we'll never say that pandas will be erased, because there are so many resources online and it is so influential, so easy to use that, and it is improving so much. End of next month, we're getting version 2.0 of pandas, so some things will change. Pandas is improving because it's using, for some features, it's using PyArrow as libraries and bindings, so it is getting better in terms of performance and in terms of window function and all the stuff that might be implemented in C and CPython and NumPy. It is really fast. So pandas will always be in your toolkit. But maybe when you need to move out, when you need to move beyond it, you might not be looking immediately directly at using, say, Apache Spark and all the overhead that it comes with it. But maybe you say, you know what, there is this nice library, haven't used in a while, but really compatible with pandas. So maybe it's worth giving a shot. Maybe if we just need to move from 1 to, 100 gigabytes, we can still use polls for that without resorting to setting up a complex cluster, spinning up something on the cloud that work for you. So you can keep it there on your machine. Like when it's predictable, all the problems of reproducibility and all the stuff like that, but you keep it familiar. This is a wonderful tool for analyzing data, like keeping the work, like scaling the work with the exploratory work, especially with the data and the big data we're getting to work with day by day. That is getting bigger and bigger day by day. Of course, we will have to use Apache Spark or Data Fusion in a couple of years, whatever, we will. But still, this pushes up the boundary, the ceiling actually, of the operation that we can do on our machine. And all the kind of interactive work that we've done, that it's easy for us to see the concrete results, to show to a colleague and work on that without connecting SSH, blah, blah, all the stuff like that. If you want to read more on this, there is like the Modern Pandas series. There is like the Modern Polars book that came out. That is a comparison between polars and pandas. The docs of polars are beautiful. I swear, even if you can't really see them, they're beautiful. There are a lot of blogs on Apache Arrow, on Wes McKinney, Voltron Data as like a blog that it promotes a bit of it. That is really nice as well. This guy is posting a lot of stuff and is posted like a couple of very old in terms of like maybe 1 to 2 years old posts on Orkes blog, which is a data orchestration platform. And it does a lot of stuff. It talks a lot about even DATDB, which promises to be the next SQLite, but for all up processing and all the stuff, blah, 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 blah. This is all the stuff like that. I am also collecting a lot of data sets and data frame libraries on my GitHub. I also have an awesome Pandas alternatives repository of the awesome, like black glasses stuff, when I try to list and collect all of them for you in case you need a reference. And if you're interested in a proper course, this guy is basically the only one that built a course, like it's on Udemy. It's fairly cheap, so if you're not satisfied by the documentation, you want to move over, I think I give them like $10 and then you get over it. I think I went a bit too long. Actually, yes, I did have, sorry for that, but it was a lot to unpack and I really want to go through the examples. I hope I haven't convinced you that we don't have to like pip uninstall pandas, but maybe it's still worth installing pip install pandas because it's easy to read and will be like a very natural transition moving over it. I'll leave the floor to Andrea with really much more like practical stuff to see, maybe to show us and practical application. And thanks for your attention. Scusi, ho sbagliato la cosa tantissimo, non ho avuto tempo di provare, te lo pinzo?
It's working, the microphone. Blah, blah, blah. Yes. I don't know. I will try to pin. Okay. Yes. I don't know if it's working. I think so. Okay. Hello. Hello, guys. Happy to be here since a long time in Python Milano. I don't know, maybe, I don't know, months, I don't know, since the last birra. So thank you so much, Luca, for the speech. It was really interesting. We're using polars, by the way. I will show you. Yes. And today I will speak about, it's less practical, say less tooling, and a little bit of ideas. I'm going to speak about some ideas about RL is not reinforcement learning, it's real life, okay? AI products, and I will try to give you some tips and some examples about what we have done in 1 year in MDPI. So I am Andrea Guzzo, I'm the AI technical leader of the MDPI, and also I'm the organizer of Python Biella group. By the way, we have stickers here, if you want, with a beautiful beer. Yes, if you want to reach me online, you can find me. And thank you so much to be here today. Today we will speak about projects, okay, AI projects in general, and what is like a reasonable scale, what reasonable scale means. And of course, we are like data scientists, software engineers, developers, and we have to build something that works, okay? This is, I mean, maybe obvious, but sometimes it's not like that. And of course, we're trying to answer to these two questions, like how can you create like a data science, AI, data-related project that works for real mean in production, and how Python is fitting in this kind of thing, and what is reasonable scale. So a lot of text. So what is reasonable scale? First of all, thanks Jacopo Tagliabue. Casavo is doing a great job doing a lot of seminars about reasonable scale. And so basically, oh, there is a laser here. I think so. Wow. Okay, so taking consideration of a company, okay? Not every company are Google, OpenAI, I don't know, Microsoft, and so on. So we have like 4 types of, I would say, simplifying, 4 types of, spoiler, companies. So we have like late adopters, someone they are coming really late in the market, doing AI, like ML proficiency, okay? We have some early adopters, someone they are doing like machine learning since a long time. Leaders in the market that they don't need help, like Google, OpenAI, this kind of people, and small animals, they are not doing nothing basically. And like I would say 90% of the companies in the world are here, okay, in this intersection. And to define a reasonable scale company means like computing. You don't have like an infinite amount of computing budget. You don't have like an entire cloud available. And you don't have like tons of engineers, okay? And the revenues of the company are like millions per year, it's okay. And you don't have a lot of terabytes data and petabytes of data, these kind of things. And of course, reasonable scale companies don't use AI as a main product tool. This is really important also, and depends, of course, maybe startups are not in this situation. And we don't really forget that each company is unique because it has unique people and unique data. This is really important, and we have Alberto here also. I want to really suggest this book. It's really nice, La cultura del dato, and they are coming also in English, I think. 4 points that I want to mention, speaking about data companies, it's like data are worth more than objects that create them. And this is really a key point. And the information extracted and the information we have to extract is worth more than the data. And the knowledge is worth more than the information. And of course, the wisdom derived is invaluable. I'm a nerd, and I really like Dune and Frank Herbert stuff. So who control the spice control the universe. So if you control the data pipelining and this kind of things, you control the universe in a company. And another really important thing is at the end, every company is a data analytics company. If you are not in this situation, probably you have to think about leaving the job and do something else in 2023. I'm joking, but probably not. Okay, we are here now to discuss about reasonable companies, and we want to create good and beautiful projects in production, but how it's possible to do it, how we can do it. And we are like data people, developers, so our job is to create something that have a value for real, have an impact in the company, in the business. And our answer, I would say, that sometimes you don't need a bigger boat, okay? Sometimes you don't need a real huge Spark cluster, but maybe you just need something a little bit smaller. And I will show you later some ideas, architecture, and some examples also. But there are some principles that are really important to keep in mind. And for me, I like the guide of my work. Data is king, as I said. We really need to be obsessed by data quality because where the marginal gain is bigger. And pass is better than yes, but about this we can argue a lot. And strive for agility. This, for me, it's one of the most important things because we really need smart data storage, and modern laptops need to be really easy to access to scalable computing, and we need really good tools to do like scalable machine learning and scalable data science. Okay, so how can we solve the problem, no? How we can go in production, basically, with our tools. And what are the data people? So our job is to create something that have a value for real. I don't know if here or at home someone is doing this job and doing like pipelining and machine learning for a living. Nowadays, there are a lot of trends coming up, especially in 2023 with ChatGPT, probably someone knows kind of things. And so the general trend one, it's nowadays the models are more and more commodities, okay? Like if you think about Hugging Face, if you think about like APIs available and pre-trained models and these kind of things. And nowadays, in a company, sometimes the data pipelines are the competitive advantage. And the general trend too, it's outside few gigantic companies, the 95%, maybe 99% of the company, you can use like off-the-shelf tools and mainly open source. Okay, so nowadays in 2023, if you do open source, basically you can do whatever you want. Okay. We are like really in the shoulder of the giants and the maintainers of the open source packages. And that can be also a problem sometimes. As I said, the machine learning, I really like to remind this kind of concept. So when we speak about AI and machine learning, actually, this is the machine learning code that you have to build to create like a data and AI project and product, okay? This is the real small box that you have to create. The other stuff that you have to build, it's like the data pipeline and the feature extraction kind of things like for example with polars. And the pipelines and the validation, the backend infrastructure, the monitoring system. There's a lot of things that you have to build around to create a software that works for real in production. So no Jupyter notebooks anymore. Okay, I want to go really quickly. I don't know when I have to finish. I have time. Oh, I'm going really fast. So 10 p.m. It's okay. 10 p.m. No, no, please. Okay, so I want to. It's okay. So I want to show you what we have built and what we are speaking about. Okay, so I said a lot of things, but what we are speaking about today. So we are MDPI. Okay, I'm speaking about MDPI. Basically, this is what happened. So my manager called me 1 year ago and he said, Andrea, please help me going in production because we have a lot of Jupyter notebooks and nothing is working now. And we have to create some tools and we have to deliver something. So this is what happened basically. And do you know papers, scientific papers? Do you read some papers? I hope so. And MDPI is one of the largest publisher in the world, and we are completely open access. So you can go there and crawl the website. Please don't do it because we have a lot of bots doing it, and it's really a problem. And but you can basically crawl and get all the data. So this is an article basically, and as you can see, we have like a lot of text collections. So we have an article is like a title, a list of authors, the abstract, and the full text, of course. This is, I think, a pre-release, an early access version, so it's not the full text. And also, we are creating this website, probably someone doesn't know about, silit.com, okay. Okay. Salit.net, okay, not .com. So this is the new version. We are indexing 153 millions of publications around the world, and this is like it's similar to Google Scholar if you want to search something. So basically, the goal for us is to create something AI products and related tools to support the publications of articles and to I would say helping the people reading stuff online and serving the contents and these kind of things. So I want to show you something. In 1 year, and we developed this platform called MDPI AI. Okay, it's a collection of our tools. And so basically, this is our main products that we made this year. And I want to really, I don't want to sell you something because it's not, but just to give you some idea on what AI can do nowadays with the Hugging Face models and these kind of things. So like a journal finder to find the best journal to publishing. For example, you're an editor, you want to go there, you go to find a journal, you type like a text, like I want to publish a paper about BERT models, I don't know, okay. And you received like a list of possible possible journals where you have to publish. And this is made by deep learning models we call the Silent BERT. I will give you some tips about. And it's trying to capture the semantic of the text and suggesting the best content for you. And there are other tools like, for example, article similarity to find semantic related articles that we published, we released the features 2 days ago. I don't know, let's try if it's working. Because as I said, we have a lot of bots querying our tools, and I want to show you why. So this is why it's so slow, and we are solving the problem. And so this is the related articles. The related articles is not based by keywords or something like that, but it's based like semantic suggestion of the text, okay, with title and abstract. We are not using full text because it's quite impossible nowadays. So this is basically what we are doing, and I want to show you how we have done this kind of crazy stuff. So what is reasonable scale for us, and how in this situation you can apply like reasonable scale. So when we started 1 year ago, we sit down to the table and said, okay, now we have to go in production. Where do we start? And basically we start with some principles that we have written down in the papers, okay? And those principles are: start with the team, okay? So we started with a team creating a methodology to work like using like a Scrum methodology, okay? And involving the owner of the data and the final user in the process. This is really important. And we have start creating building blocks. This is the most important things. So what are building blocks? Building blocks are like Python libraries that we have in our PyPy internal repository that basically we are installing in every project. So for example, in every project you go, you have data layer shared to every project. So every time there is something, we make a new release of the PyPy package, we install in our tool, and then we have the new version. So every time we don't have to go in every project to like changing crazy stuff and this kind of things. And for example, we start with Cookie Cutter doing templating. So the template for API, the template for, I don't know, the Streamlit dashboard, the template for the package that we are building. So I said to my boss, please give me 1 year. I will start doing 3 years without producing nothing, and 3 months without producing nothing, okay? In these 3 months, I would start creating building blocks. And then after 3 months, we will start maybe doing some like real, real tool. And unfortunately, my boss gave me a lot of like trust, and we have made it. So another important step is coming from startup. It's get out of the building. Okay, this is not from day zero, but you have to go in production from day zero. So the first day we set up the GitLab CI/CD pipelines, and to do like automatic release, testing, linting, and everything in the pipelines. Now we're using pre-commit. We'll show you a little bit of this kind of things later. And the shiny object syndrome. The last release model and technology doesn't solve your problem and our problem. This is another important step. So don't follow the last, let's say, shiny object. Keep the model that is working. Sometimes the small models is working better than large new models. And no manual processes, as I said. There is no manual interaction with the production systems, so everything is automatic, and no excuses. So if you can't build with what you have, I mean, you have what you have, okay? You cannot invent something from scratch. And this is really funny because the first day I said, okay, I need Azure or I need AWS to have some services. I said, no, we don't use cloud here. I said, what? Okay. Yeah, we are in 2022 and 2023. We don't use cloud. I mean, how it's possible? And I said, no, we have our data center, and we are doing everything our own. So you don't have like an AI service. I said, okay. So what are the solutions? What can we do? So we decide to do like normal stuff without cloud services and these kind of things, because it's the only way that we can achieve our results. So that's why no excuses. And sometimes that's why big reasonable scale, sometimes sometimes it's enough. So what you have, it's enough. Sometimes having a good VM, it's enough of what you are doing. This is another 2 important steps. It must work for the customer. This is really important. And our customers are researcher and everyone that wants to read the paper. And the why, it's the last one, but not the least, the research question. It's the beacon in the night. So we started designing our projects and products saying, okay, what is our client, what is our customer, what we have to do, what is the research question we want to achieve. And this is basically our rule that we define before start creating code, okay? And this is our workflow we built. Now it's working quite similar. It's a simple representation. We have done everything in 1 year with 3.5 people. 4 people, now we are 5. So not because we are good, but just to give you an idea what is a reasonable scale. I don't want to have any applause on this. So we have a data scientist. They're doing like experimenting and evaluation and documentation. This is really important. So you start like experimenting with Python code, no Jupyter Notebooks. Sometimes we use Jupyter Notebooks. And we are doing the first things the data scientists do. It's the evaluation and documentation after the experimentation. Documentation, it's really important. It's the key, okay? And then we define the products, we design the products, and the product, all our product, it's following a micro repo approach. So we have a repo for the backend, a repo for the front end, a repo for the ETL, and a repo for the model. And we deploy in production, of course, everything is on GitLab. So GitHub registry, GitHub pages, we have the runner in our servers, and so on and so forth. And and this is the architecture that it's working, that I show you. So I want to spend a couple of words here. As you can see, everything is in Python. Everything is in Python. Okay, we don't use nothing else than Python. Of course, we are using other stuff like, for example, Postgres, Grafana, Prometheus, and kind of things. But so we have 3 large collections of data. And as I said, the largest collection size is 152 millions of data of articles. So I would say it's not a big data approach and data collection, and we are not doing real-time analysis and streaming analysis, okay? We are using Airflow. As you can see, it's called MD Pipe because we take Airflow and we customize a lot. So there is we customize Airflow basically to use some of our building blocks. Those are the building blocks like the data connector, and the data connector is the data part, okay, that we have in our projects. Notify me to send notification Teams if something broke. Those are the models that we are using. We are using Spectre. It's a good model from Hugging Face. We use the pre-trained version because inside there is the information of citations. And we train our Scilit BERT. So we train our BERT model. So now we have our BERT model trained on this collection. And this training here took us, I would say, roughly 6 weeks on a single GPU machine server. So you need a super huge cluster. I don't know, probably not. Maybe if you are OpenAI, maybe we have to start writing a better code, probably, sometimes. And we have also, we created 2 packages. One is called Swordfish and one Acadx to have these models and these interfaces on top of PyTorch and Hugging Face to easily, I would say, manage all these kind of things. And as I mentioned, this is Tempi. Tempi, it's our template system in Cookie Cutter. And Fast API for APIs with a Redis cache and Celery. and Streamlit as for the dashboards and for the front end. Of course, we are start doing like proper front end with React and Vue.js. We are fighting a lot to choose. Yes. And this is basically the key clock authentication. It's a really good project from Red Hat, actually. If you want to do like authentication systems. And everything, as you can see, Teams, Jira, SharePoint, and blah, blah, blah. And FlowMe project, it's our implementation of MLflow. And as you can see, everything, we use only open source stuff except Neo4j. We are paying a lot of money, actually. And so this is basically a complete architecture, and we are serving like 5,000 users per week with this architecture, with just only 3 virtual machines and Docker, basically. Actually, everything that I show you also on the website and stuff like that, it's on Docker, and so we want to use really Kubernetes and these kind of things, but we are installing now and doing now. It's quite complicated to maintain sometimes. And yes, so regarding Tempi also, I want to show you something because I've done a presentation in Python Biella group, I mean, the past week, last week. So if you want to, are curious about this, GitHub, Python Biella group. So, okay. So everything that we have done in, that we are building in MDPI, it's roughly, not everything, something. It's here in this package called, in this repository called Bear. Bear, I don't know, I know this. Okay, maybe, okay, like this. Bear. No. Okay. Okay, yes. So if you go there on, no, okay. If you go there on Bear, you can find, I would say, a modern Python cookie cutter template that you can use also in your projects with a lot of stuff. And if you want to help us also to debug, we are using also in the Python Biella group projects. So we are trying to give to open source what we have taken from open source. It's complicated. So I don't know. Little by little. So, okay, coming back to the presentation. By the way, inside the, where is the presentation? Okay, inside in the pipe there is pandas and polars also. So, okay. So, what we want to prove, what are the takeaways of today? I think I finished. That's okay. So it's possible to create good AI project with a reasonable scale resources. We are not geniuses. We are just like nerds. And so if we made these kind of things by ourselves, I think everyone can do it without spending a lot of monies in cloud providers and this kind of crazy stuff. And it's not complicated in the modern world now, because if you go on Hugging Face nowadays, I'm sorry, I opened your history. I don't know, maybe so if you sure understand. Yes, thank you, Siri. So if you go on Hugging Face, as you can see, there are a lot of tons of models that you can use, basically made by great people. And you can find also with ONNX pre-trained models. You can find a lot of pre-trained models. It's called Model Zoo that you can use. So basically the AI models, except if you have to do like some really custom things and really core, are pretty much, I would say, available for everyone. And I think you just sometimes need a good working philosophy. So if you step back a little bit, if you think about what you are doing with your team and with your colleagues, and you have the freedom to do it, maybe having a good working philosophy and thinking on what you are doing for the customers and for the people, sometimes it's enough. And of course, you have to start coding later. So that's it for me, and thank you so much. There are stickers here of Python Bella Group. It's not written Python Biella Group, but now you know that the beer, it's the Python Biella Group logo. So thank you.
Oops, Amica. Okay, thank you. Thank you, you both. You have been great, both of you. So, if you want, someone of us will go out and take a beer together. Yeah.
Like beer, not bear, because we've had
Yeah,
enough.
beer.
To bed, we've had enough.
No, for the bear we have a sticker here for Python Biella Group. No, because it's Marco, and so it's a best effort stuff. So there is no reservation. So we just catch up here and go to a pub.
Oh, maybe I don't know if someone has questions.
Oh yeah, somebody of you have a question for Luca? It's really tough stuff. So I don't know if the people at home heard about the questions. The question was, the question is PyTorch or PyTorch? So it's PyTorch because the Hugging Face.
Okay, yeah,
No.
totally.
Yes. But TensorFlow, if you're doing embedding system, maybe TensorFlow it's better. Depends of what you're doing. Like, yes. Questions? Don't be scared.
Yes.
Yes. Okay. Oh, no, it's okay.
I'm not either, so.
Okay.
Thank you. As a non-expert, I wanted to ask, what does lazy processing mean?
Oh, right. So, it's a bit like when you're talking about, especially in the TensorFlow and PyTorch debate, eager mode, lazy mode. So, basically, when you say, I don't know, maybe PD, read the CSV, and then you say drop, and you drop or all columns except one. What Pandas does is working in eager mode. So it reads all the data into memory and then drops all the columns. So it has to do the job of reading every bit of data, even the columns that it doesn't need, and then dropping them. And this takes time because it has to read everything. When you do lazy processing, basically you write the operations, and then these operations are translated into a plan, or as you would say in the deep learning frameworks, like a graph. And then the query engine simplifies the graph. So, for example, given that you can say PL scan CSV, select one column, for example, but you can also do it like at an even lower level. You can say PD, read Parquet, and pass name of only the columns that you want to read. Given that Parquet is like a smarter memory format, it will just look at the data and open up the packets which contain the columns that you do need. Parquet is even smarter than this, because not only it stores compressed the data, the values, but it also stores it in chunks with metadata about it. So for example, you have a column and which contains a date. It will also store the beginning and the end, for example. Or with a metric, it will store the minimum and the maximum of a quantitative column. And so when you say PD dot, I don't know, or something with query engine, with PyArrow, it will look back at this memory mapping of the data set and will just look at the metadata and open up only the chunks where the max is. So because Pandas would have to look at the whole data set, so read it all into memory and just find the max there using a highly optimized NumPy written function. When you do it with a lazy engine and polars and PyArrow compute actually, so that's a more of a like lower level in PyArrow implemented that can be done by anyone that implements PyArrow, y compris Pandas, it will just look at the column, look at the chunks of the metadata and say, this is this, okay, this is the biggest one. And we just read that value. So it will save up a lot of memory in reading the data. And this is all where it came down to. We have ginormous amounts of data. So we cannot just brute force them. We cannot just throw RAM at it. We have to work with the resources that we have, both in terms of like economical, but also like on current state of affairs processes, and be smart about how we look at it. And lazy evaluation is a smart thing. Maybe you don't want to use it constantly, because maybe you want to like an immediate feedback, but with polars it's really easy to go up and on and off from eager to the other one. I don't have a lot of experience in Apache Spark, so maybe some of you can tell us how complex it can be to give have a real-time feedback or like an eager mode evaluation of stuff that is taken from Apache Spark. Maybe you haven't, but we don't do that here. Okay, hope I answered your question. Anything else? Please.
So another question about polars. From your talk, yeah, you know me. I know you. From your talk, it looked like polars is superior in every aspect to pandas. So my question is, where should you use pandas and not polars?
Is this working? Okay, wonderful. I don't know. I think all in all, it boils down to preference. In a way, if the data set is small, in I don't know, hundreds of megabytes, maybe a couple of gigs, and you have a decent laptop, stick to what you're familiar or more comfortable with, or given the constraints that you have to deliver something really soon and you want to pick up a library. My point is, maybe when you hit the ceiling, then you can just extend your usual workflow with polars, if you feel, and it would be easy. Maybe one day it can replace it, but as of now, I think Pandas is an extremely wide API surface, so it might have more function, exponential window, exponential function that are only there, or there's lots of better documentation, like exploded documentation, and also tutorials, people online, people writing on it, maybe like a more curse community. So there are lots of developers, maintainers, people that stream constantly how it's developed. Also, Pandas is written in Python, so development is easy. If you find something to fix, then it's easier to open a PR and have it fixed. If you need to fix something in polars, good luck with Rust. So if you are maybe an end user, it's easier to switch. If you are more of a developer, if you need to work on internal package and stuff like that, you have to be a bit more careful and cautious. Did I answer your question? Yes. Okay. Thank you.
Can I say something also?
Sure. He has more practical experience with that.
Use polars when Pandas is not working.
Like the practical wisdom of reasonable scale.
Yes, no. It happens.
It makes sense. I mean, we're trying to solve it. Sorry.
No, it's okay. Thank you. No, it does make sense. I mean, I was asking the question because we are hitting the ceiling of Pandas right now in one of our projects. So for us is a very nice solution. I didn't know about that. I mean, I knew the name of the library, but I have never seen it in action. So thank you very much. If I may follow up very quickly on the previous question, I also would like to ask, Pandas has many tools which build on top of Pandas. For instance, Pandera for schema validation, for schema and value validation, and so on. How is the ecosystem of polars? Is it as developed as the Pandas one, or is it a little bit behind? Thank you.
Yes, that's the other pain point I completely overlooked. It's not as developed as it is. For example, I cannot guarantee, I mean, I think it will work on plotting libraries. So, but do not expect to work. Actually, I asked this question to the developers, to the core developer of the Polars, and it was like, yeah, you know, but we have zero copy. So transformation from a Payaro table, that is basically the data type behind it, like the core that inherits everything from it. And you can just zero copy it and make it like an NumPy array when made. So you can quickly access all the external ecosystem that is extremely well developed in Pandas and NumPy and stuff like that, the compatibility with scikit-learn 1.2, now that we have it. You just cannot I think you cannot really expect to say, okay, matplotlib, PLT, blah, blah, and just throw everything there. You just have to do one smaller step into NumPy, but that does work, and it is fast because it is zero copy. So in a way, you can very quickly access to it. Haven't found any instances where I find like an exotic tool where it doesn't work, but given that there is zero copy, this should be possible on any other library that you use there. Thank you for the really important question. Then, okay, it was a pleasure. So Lorenzo had to leave because he had a meeting and stuff like that. So I would like to thank you in this part for coming here. Really proud that Futura is hosting this event, especially for Python Milano. We'd like to give back to every other community, especially the Python community, because we're heavily using it as well. It was a pleasure having you here. We hope to see you again, and I'll host another event here soon. As a side note, we're looking for a middle front-end developer, so if you're interested, I'm here. You know where to find us on LinkedIn. It was a real pleasure for everybody here in Python Milano to organize all the event, all the attendance. It's an amazing crowd. The effort that you put into all of this is wonderful. So we're really walking on the shoulder of giants. So thank you. It was a pleasure having you here tonight. Good night, everybody. If you want to say something, please.
Ciao.
Congratulations for your wonderful talk.
Thank you.
You've been an amazing crowd. Grazie. If you want to say something final?
No, it's okay. So thank